sometimes we want to compute the area of the curve under the curve, right? And we cannot find the exact forms of that. Or sometimes in real life, we have some measurement of some experiments, which is the result of some integral. And we don't know the exact forms of that. So how can we find, the question is, can we find the approximate result of these integral, for example? And the answer is yes. And in this chapter, we'll study these things. Okay? And from definition, as you remember, an integral from a to b of the integrand fx here with respect to the variable x, we can write it as a sum from I is equal to 1 to n of fxi star delta x. And when we take the limit of n goes to infinity, this will be the definition of this integral, right? And if the number of n points, the grid here is finer and finer, it will approximate the area better and better. Okay? And if the xi star here, okay, look at this. Suppose the graph of the function fx is given by this blue line here. Then the xi star, the interval from a to b is discretized to 4 intervals here, right? x0, x1, x2, x3, x4. If the xi star is the approximation of the left endpoint of each interval, which is, for example, in this interval, the left endpoint is this one, right? The area of this rectangle will be this rectangle, the left endpoint. Similarly, at the second interval, the left endpoint of this will be this guy, right? Okay. And the rectangle of the second intervals will be this red one. And similarly, the third one will be like this. This looks quite similar. And when we discretize the intervals smaller and smaller, the sum of these rectangles will be come closer to the area of the true curve here. And in that case, we call it the left endpoint interval. And this formula will express what it is. Okay? Integral from I is equal to 1 to n of f of xi minus 1 times delta x, where delta x here is b minus a divided by the number of the rectangles here, n. Similarly, if we pick the xi star, here is the right end of each interval, like this graph here. We call it the left end formula of this integral, which is the sum from I is equal to 1 to n of fxi times delta x. Okay. And the midpoint rules, if you pick the xi star, is exactly the midpoint of the interval from xi minus 1 to xi here, then the sum of these integrals in the rectangles will be delta x, which is the width, times the height of this midpoint, which is f of xi bar, right? And the same story, delta x is b minus a over n, the average of these middle points. Okay? We call it the midpoint rule. to approximate the result of this. But now, if we take an average of the left endpoint rules and the right endpoints rule, we call it trapezoidal rule here. So just some derivation, yes. No, it's not. Look at this. It's a very good question. I'll look here. The left endpoint will be sum of this from f of xi minus 1 delta x, right? And the right end formula here will be from I is equal to 1 to n of fxi delta x. Let us just take a sum of them, okay? Because delta x are the same for both, so we can factor it out. And average of them will be 1/2 of these two formula, okay? And when we do some algebra, we see that this is the average of the left end rule and the right end rules. It is different from the definition of this guy, because here it is delta x times f of this middle point. The middle point here is the middle point of the intervals, right? Fxi bar here. And the trapezoidal rule here, we take the average of the previous point. And yeah, you see, okay, just derive it. You see the different average of the previous point and the next, the left and right point, which is this guy, okay? Average of them. Okay, now let us just take an example and study it, okay? Suppose we want to compute this integral numerically. If you do this by taking the antiderivative of 1 over x, which is natural log of x here, from 1 to 2, it's easy. It is natural log of 2, right? Use your calculator. You see that it will give us this number, okay? Now, let us try using the trapezoidal rule and midpoint rule and see how it looks like, okay? First, look at this. Suppose this is 1, right? This is 2. Then delta x will be, what is it from the formula? Upper limit. Yes. Which is 1/5, right? Here. So this distance is 1/5 delta x here, right? Or we can write it here. It is, this is the corresponding numbers, points will be x0, x1, x2, x3, x4, x5, right? And the very useful formula, xi will be x0 plus I times delta x, right? Therefore, it makes sense that x0 is 1, right? And x1 will be 1 plus 1/5 here, right? Or if you want to write it in this form, okay? x2, 1 plus 2 times 1/5 here. What do we have? Yes. This is 20, right? Sorry. Just 1.2. And here this is 1.4. Okay? Like that. Now, x3, or you can look at this. You see that it is 1.6, right? And x4 will be 1.8, and x5 is 2. Okay? The trapezoidal rule, what is it? We can copy this formula, memorize it. Okay, let us do it. Integral from 0 to 1 of 1 over x dx up 1 to 2. Thank you. It will be delta x, which is 1/5, right? And times 1/2 here. And f of x0, which is f, let us write it this way. F of 1 plus f of 1.2, f of 1.4 plus right? Now the function f of x in our case would be 1 over x. Therefore, this guy becomes 1 over 10. Very good. Thank you. The first one, it will be 1 over 1, right? The second one, it will be, yes, you can do it this way. Or 1.2, remember, 6 over 5, right? Same things. 1 over okay? Yes. Oh, yeah, yeah. Very good. Yeah. Thank you. That's a good catch here. The parameter coefficient here is 1 and then 2 here, right? 2, 2 of these, 2 of this, and 1 here. Very good. Therefore, this guy is 2 times this. Okay, good job. I purposely write this way because we can write it in form of fractions, right? And it is somehow reminds you how to deal with fractions here. 1 divided by 6/5. It is the same as, we can flip it, right? Reciprocal, it is 1, and here, yes, 5/6. 1 divided by 6/5 will be 1 times 5/6. Very good. 2 times here, 5/8. And here it will be 1/2. Okay. Because I saw some mistake in the exams, so remember with this. Okay, then finally, what are they? Go home and compute it yourself. To save time now here, write the final result of this only, which is approximately 0.695635. Okay. That is the trapezoidal rule. Okay. And the question B, the midpoint rule. Okay. The midpoint rule. Look at this. The midpoint here would be this point, this point, this point, this point, and this point, right? So do the same things. It will be integral from 1 to 2 of 1/x dx, which is delta x times f of x1 bar plus f of x2 bar plus f of x3 bar, right? Plus f of x4 bar plus f of x5 bar here. And remember, the formula that xi bar will be xi minus 1 plus xi times 1/2. Okay. The average of these two. Therefore, it will be delta x is 1/5, right? F of x1, let me write it this way. it will be the middles of 1 and 1.2 here is 1.1 first, between 1 and 1.2, right? The middle point. And the second one is 1 over 1.3, right? And the next one will be 1.5 here, right? And 1.7 and 1.9, right? Okay. Use your calculator, you see that it will be 0.691908. Okay. Okay, look at the notes I gave you. Let us copy this result. Paste it here. And this result, paste it here. Okay, they're quite close to the number when we use the exact formula here, right? 0.691, and this, the exact things will be 0.693, and the other rule is 0.695 here, etc. So, and the error, the definition of this, the error is in this approximation is defined to be the amount needed to be added to the approximation and make it exact. And the error of this trapezoid rule here is this number subtract this exact number, and which will give us this negative things is below. And the midpoint rule will give us this result. Okay? Or memorize it. In the future, the error will be the difference of the exact things and the approximation forms here. The error of trapezoidal rule here and the error of midpoint rule will be the difference of them. Okay? And these are the two tables approximating this integral from 1 to 2, different method. The left hand rule, the right hand rule, trapezoidal rule, and the midpoint rules. We see that the numbers of points here, of the numbers of rectangles, if we increase this number, the result will come closer and closer to the exact number. Okay? And the corresponding errors of these approximations will be given in this table. And tomorrow, we will continue with this. Here are some properties. Let us take a look at this together. It will be more accurate when we increase the numbers and values, right? The value, numbers, points. And the error of left and right endpoints approximation are the opposite in sign, so appear to decrease. by the factor about 2. Oh, I mean next week. And the trapezoidal mid-root point rule are much more accurate than the endpoints approximation. Okay, the error of thumb decreased by the factor 4. Yeah, so these are some properties, and I will see you next week. Oh, by the way, next Tuesday is holiday, so see you on Wednesday. Okay, happy holidays.